So, welcome to another lecture. In this lecture, we'll try to understand these terms: isotopes, isobars, isotones, isodiaphers, isoelectronic. So, isotopes are something, uh, the proton number is the same, the neutrons is different, and consequently, the mass number is different, and the electrons are same. So, let's try to understand this with the example that I have taken. So, I've taken example of C12, I've taken example of C13, I've taken example of C14. As I've told you earlier, there would be other examples mentioned in your book, but I want to make this lecture as simple as is possible. And uh, you can refer to your book or you can Google it. Now, when we look at these three kind of carbons, see, ultimately all three are carbons. So, because they are carbons, the atomic number would be the same. Because the atomic number is the same, the number of protons would be the same. And because the protons are the same, the electrons are the same. Then what will differ? The only thing that can differ is neutrons. So that is why isotopes are something whose, uh, as you know, the atomic number of carbon is 6. So number of protons and number of electrons would be 6. But as you can see, the number of neutrons changes. In this case, the number of neutrons is 8. In this case, the number of neutrons is 7. In this case, I'm sorry, the number of neutrons is 6. The number of neutrons is 8. But the number of protons and electrons remains the same. It is 6. I hope it is clear. So isotopes is something where the atomic number would be the same. That implies the protons and the electrons would be the same, but the mass number would be different. Now, I hope you know this. If there is any doubt, I'll repeat it here. Usually, students are aware of this. You should understand this, that the atomic number is equal to number of protons is equal to number of electrons. The mass number is equal to number of protons plus number of neutrons, for a simple reason that the mass of electrons is negligible. Negligible implies that it can be ignored. So these are the two critical things that you should understand. Try to do few numericals also, where practice numericals to understand what is atomic number, what is mass number. Only then you will be able to understand these isotopes, isobars well. So as I have you know repeated at least twice, two to three times, in isotopes the atomic number is the same. Number of protons and electrons is the same. So what will differ is the neutron number. And because the neutron number differs, that is why you see here the mass number is different. So I've taken example of carbon. There are other examples. You can refer your textbook or you can Google isotopes. You will get lots of examples. Now let us come to the second term. The second term is isobars. So what are isobars? Same mass number, different elements. So let's try to understand this. The the mass number is the same. So for example, we take the example of 14C6, which is carbon, 14N7, which is nitrogen, 14O8, which is oxygen. Now look closely. The mass number is the same, 14, 14, 14, but the atomic number is different. See, one core idea that you should understand is that atomic number of a certain element would be the same. As discussed in isotopes also, see, 12C, 12C, 13C, 14C, all three isotopes are carbon because the atomic number is the same. The number of protons is the same. So, but in this case, the mass number is different, but the number of protons and electrons remains the same. So, for example, this case, the number of protons would be 6, number of protons would be 7, number of protons would be 8, but mass number is different. So, in this case, the number of neutrons would be 8, the number of neutrons would be 7, the number of neutrons would be 6. I hope this is making sense. So isobars are something that the mass number would be the same, but the atomic number would be different. So that is why it is mentioned protons are different. Number of protons are different. Uh, Number of electrons would also be different. This would also be different because the protons are different. But the neutrons would also be different. But what would be the same? The same would be the mass number. Hope this is making sense. Isotones. Let's try to understand what are isotones. Let me make some space here. Isotones. Isotones. Same number of neutrons. So number of neutrons are same. But protons and electrons would be different. Proton and electrons would be different. Let's take the example to understand. So 14C6, that is carbon. 15N 15N7. So 15N7 would be one of the isotopes of nitrogen. So if we take this example, in this example, now look closely. Number of protons is 6, number of neutrons, number of protons is 7. So number of protons are different. Because protons are different, the electrons would also be different. Atomic number is also different. But look at the neutron number. 14 minus 6 is 8. Number of neutrons is 8. 15 minus 7 is 8. Number of neutrons is 8. So entities where the neutron number is the same, where the neutron number is the same, but protons, electrons, uh, mass number, atomic number is different. They are called isotones. 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 Okay. I'll skip isodiaphers for a while. I'll jump to isoelectronic. So isoelectronic, what is isoelectronic? The same number of electrons. Electrons are the same. Now here, this is an interesting. I've taken some interesting examples. Neon, sodium plus, Mg2 positive. Uh, let's focus on these three only. Now neon, neon atom. The number of electrons would be 10. Sodium positive. See, the atomic number of sodium is 11. So Na positive, uh, one electron is less. One electron is less. So Na positive will have 10 electrons. Mg, magnesium. The number of electrons in magnesium atom, that is 12. But Mg2 positive, that is 2 electrons are deficient. So consequently, the magnesium 2 positive will have 10 electrons. Will have 10 electrons. Now look at these three entities. Neon, Na positive, Mg2 positive have 10 electrons each. So that is why they are called isoelectronic. Iso means same. Iso means same. Now let's come to isodiaphers. Usually I haven't seen this in textbooks, so that is why I'm taking it in the last. Students are usually sorry. Students usually focus on the isotopes, isobars, isotones, isoelectronics, electronic. So isodiaphers, same neutron proton different, same neutron proton different. Let's try to understand this. So uranium is written as 235 and the atomic number is 92. Thorium, at, at mass number is 231 and the atomic number is 90. Now I have done the calculation here. So see, atomic number will give us the number of protons. So 92, in thorium it is 90. Using the mass number, I can calculate the uh, number of neutrons. So in uranium, the number of neutrons is 143. In thorium, the number of neutrons is 141. Now, when I do neutrons minus the proton, neutrons minus proton, Neutrons, see, neutron minus proton difference. In uranium it is 51, in thorium it is 51. So uranium 235 and thorium 231 will form a isodiapher pair. If you want to take another example, so another example is this is another example that I have taken. You, if you want to refer to the calculation, you can refer to the calculation here. I don't want to go into the detail. I don't want to make this needlessly complicated. But for people who are interested, they can look at this calculation and they will find that in this case, the n minus z difference is 52. You can look at the calculation. So the key points to remember, just to recap, isotopes Z implies atomic number. Atomic number implies number of protons. So isotopes same atomic number. Isobars same mass number. Here A sorry A is mass number. Mass number. It is written here. Mass number. Isotones same neutron number. Isodiaphers, the difference is the same. Isoelectronic same number of electrons. There is another important term which is usually mentioned in the books. Please don't confuse this. Nucleides. Nucleides are the entities which reside in the nucleus. So we know proton and neutrons reside in the nucleus. So nucleides, whenever you see a term nucleide, it means they are referring to neutrons and protons. So isodiaphers are nucleides that have same difference between the number of neutrons and protons. N minus z is constant. So I hope this was useful. I have tried to keep it simple and short. And as I've told you before, if you want more examples, you can refer to Google or what we mentioned in the textbook also. So let's meet in the next lecture. Best of luck and take care.